Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
This edition to Insider's Guide to Energy is brought to you by Fidectis. Go to www.fidectis.com for more information.
Welcome to Insider's Guide to Energy. I'm your host, Chris Sass, and with me is co-host Johan Oberg. Johan, how's it going this week?
Another great week, Chris. Good to be on. Really interesting to see all the interest from our mini-series. Good to see the feedback we're getting, the questions, the ideas, the sharing, of course. But one thing just struck me after Christmas when we came back, starting doing the show, that we're actually hitting 50. We never had a celebration around our 50th episode. So, you know what I did, and I think you shared some of them as well, is I put up my personal the best of. So for you guys who haven't seen it yet, get into the LinkedIn profiles and start looking at my countdowns of my favorites of the show. But Chris, it wasn't easy. We have so many good guests on this show now.
Yeah, at this point, we are getting a lot of content. We've had a number of guests. The exclusive club that our guests join is getting bigger and bigger, but it's still fairly exclusive. I think we're still under 100 or getting close to 100 when you put all the shows together. But yeah, I did see your post. I've got to go through and look through your list later and really just see if it aligns to my favorite shows so far. And it'll be fun for our audience to do the same. So if you see Johan's comment, and you think differently, you like it, give him a thumbs up. You're not so sure about it, don't be afraid to let Johan know, because I certainly will.
Honesty is our best friend.
So let's switch gears and talk about this week. So there was a lot with the podcast. Like you said, the mini-series has been out. By the time this episode's out, we've had a couple of weeks of the mini-series out. So quite a bit of interest there. How about the energy industry? Any news there or anything interesting that you want to talk about this week?
I think in general, the big talk of the town is outside of the energy industry now, and that's the energy prices, of course. There's no doubt about it. All the families, I have all my friends back in Stockholm, Sweden now, putting up a receipt on their energy bill saying, what the hell is going on? That's my vacation money gone, etc. So obviously there's a big talk about the energy prices.
So prices, yeah, that's been something we've been predicting. We've been talking about going into the winter. So I don't think it's a surprise, but I don't think it makes it any easier.
No, I think it's more comes down to the consumer business, to the consumers now, which we might not have seen in the same way as we discussed on this show. But at least talk of the town.
I have to agree with that. So you're kind of a downer at the moment. I want to talk about what we're going to talk about this week, because that is not a downer. It's pretty exciting. What we've done in the show, for those that have listened to many of the episodes, and I'm going to bet some of those are in Johan's playlist, we've talked about battery, we've talked about storage, we've talked about EV vehicles, but we really haven't spent much time, other than maybe on hydrogen, talking about marine and marine applications as well. So I'm hoping we're going to get a good feel for that and where that's going in this episode. Because to me, if I look at it not just from an energy perspective, but from a global warming and a CO2 emissions thing, marine can be a problem. Marine's problematic.
No, I agree. And I think I'd be really interested to hear also what are the differences between, we talked a lot about EVs. This is what I understand, a totally different ballpark. This is a different game. We're talking, ships, we're talking marine. This is, it's going to be really interesting to see. And also, as always, not being the entrepreneur on the show, it's always interesting to see how you guys as entrepreneurs are entering these large industries and working with companies like ours that are the big utilities. That's always fascinating me, what the drivers are. So a lot of things to think about and to listen to.
Well, before I introduce our guest, I just have to call you out. When you work for a Swiss company and can call yourself a big utility, I have to call you out on that, because yes, you're big and you're in many countries, but big utility?
Big on hydro.
All right. So without further ado, this week we brought our guests in. We have Magnus Eriksson, CEO and founder of, how do you say your name?
Echandia Marine.
Echandia Marine. Sorry, I apologize for that. I want to welcome you, Magnus, to the program. It makes sense for you to maybe share a little background of who you are. So we gave a little history of what we think we're going to talk about. But as always, Johan and I have no clue what our guest is going to say. So let's start by your personal background. How'd you get into what you do, and a little bit more about what you do professionally?
Yeah, sure. Yeah. First of all, thank you for inviting me to the show. I'm glad to be here today. It's a new experience for me, being part of this type of podcast production. I'm Magnus Eriksson. I'm based in Sweden, native Swede, and my professional background is within naval architecture. So I've been working for about 20 years developing Swedish naval systems and primarily Swedish submarines. So in various positions, I've been working with developing energy systems, electric propulsion systems, and Swedish submarine flotilla has been going for over 100 years, and they've been operating on electric propulsion systems ever since the beginning. So this is like, I'm talking about.
Well, that's what came to mind when we started talking electric marine. I think of, the old submarines that ran electric underwater.
Yeah.
Granted, I believe they ran diesel when they came up to the surface, but they were electric boats at one time, I believe.
Yeah. Yes, absolutely. And also in terms of the hybridization, batteries and diesels and all this stuff has always been part of the energy mix on these type of vessels. So I started off my career there and doing a lot of R&D work and systems developments, etc. And I was rewarded with a few patents in 2005 or 6 or something like that regarding electric propulsion systems, and primarily more directed towards torpedo propulsion systems. But anyhow, I sort of quit my day job then, and then started off doing some electric pleasure boat designs based on these type of innovations that I was then working with. But it was too early on in the market. I quickly realized there's not a viable market for electric pleasure boats at that time, 15 years ago.
But I have to tell you, I'm a sailor. We have a Volt drive on a boat. It's about 34 feet long. And it was wild the first year of using that boat, because you would get on to leave the dock and it was absolutely quiet, and you had no feedback loop of the vibration of the boat. You could get the propeller to cavitate because you put the throttle up and all of a sudden you're cavitating your propeller. I found it great for club sailing. So when we just out around the harbor sailing and stuff, where it was challenging still early in its development is if I had to do a delivery on a no wind or a long day of motoring. Didn't have the battery capacity to go for 8 hours or 10 hours or something like that. So easier to put some jerry cans of fuel on a boat and make the whole journey than to have a little Honda generator on the deck powering the boat at that time. And that's only been the last 4 years, right? It's not that old a technology.
No. There are so many initiatives going on now in the pleasure boat industry, but we as a business moved into the commercial space in 2014 when we launched the world's first supercharged electric ferry operating in Stockholm. And it's funny when you say cavitating propellers, because the skipper, we recruited a skipper, and he was obviously quite familiar with operating diesel-driven ferries. And he knew, like when he was driving at 5 knots, he knew that he was driving 5 knots because of the vibration in his back, because the engine was making so many vibrations. And when we converted this vessel into electric propulsion, he was completely lost. When he was entering into the harbor and going into the quay, he didn't know how fast he was driving because everything was silent. So he has started to look at the GPS and all the nav stuff. So quite interesting experience. All of a sudden, you have a completely different sense when operating these type of vessels. And gradually moving on from there, we built a number of really cool projects. Another cool project is the fastest battery-driven ferry in the world, a 30-knot passenger ferry called BB Green. We built that one 2 years later in 2016. And so we've been taking step by step, and it's not until quite recently I feel that there's like a really strong momentum in the market. Where also it's not an idealistic market. It's more like driven by political trends now, and it's more of a cohesive trend. And also looking into the financial markets, you need to be have a sustainability profile to attract funding. So it's more of a very cohesive momentum ongoing right now. I feel strong winds, and I would say this development is quite recent, maybe in the last 18 months or something, and increasing. So more of my private or personal background, I'm a bit of an entrepreneurial spirit, so I have hard to say no to new interesting projects, and I think that is the reason why I've been achieving a number of these type of projects. It's just because without any prior experience or proper knowledge, I just been assuming that we can deal with this and we will make it happen. So that's how we got this far anyway, and now we're moving forward. So as a business, we're quite a small business based in Stockholm, and also a new entity in Canada. So the battery business is based in Stockholm, and our fuel cell development arm is based in Eastern Canada, which we set up in 2021. So currently employing about 34 people here and in Canada, and growing by the month. So primarily now within the commercial organization with marketing and salespeople, we need to increase our capability.
So out of interest, Magnus, you mentioned Sweden and Canada. Obviously, being Swede, I know a little bit about the Swedish market, especially Stockholm and the archipelago. And that you have development centers in different countries, I can understand. So how did it end up with Sweden and Canada? They're not really the normal, so to speak. Or
no,
is there a natural connection?
Yes, it is absolutely. The Canadian connection is a bit of history here there, where I have been working with some partners over there for a few years doing design work for marine fuel cell systems. Canada are quite well represented in terms of fuel cell competence because of the various businesses related to fuel cell developments there. So these guys I'm working with here, we were set up this joint development entity, have a broad experience from Canadian fuel cell companies, basically. So that's the reason why we're based in Canada. And Sweden, yeah, I don't know. I'm Swede. That's probably the simple answer to that.
But going back a little bit to what you mentioned in terms of the electrification of the marine industry in general, and of course this is a massive industry, and we can break it down to what you mentioned, to ferries, to deep sea, and all the rest. And you said that in the last 18 months you're starting to see this. For example, we have pleasure boats with X-Shore getting a lot of traction, at least in the media from Sweden as well. But where do you see the differences? Because we have EVs everywhere. It's on the streets now. There's no doubt about it. A few years ago, there was maybe some discussions. Now it's all EV. How do you see comparison or differences with kind of the marine versus the EV?
Well, looking at the commercial application, first of all, the requirements as such, the technical requirements on the application is vastly different. It's much more demanding applications for maritime because of what we define as heavy duty type applications with nearly 24 hours of operation, with numerous charging events for a battery system in a day, and very long warranty times are required. So typically roughly 10 years full value warranty times in these type of heavy duty applications. So to compare with an EV system, it would last maybe a year or two in this type of application before you would have to replace the battery system. But in our case, the type of battery system we're developing and supplying to the market is the most reliable and durable battery systems available in the market. And of course, the initial upfront investment for our type of battery systems is slightly higher, but the total cost of ownership is considerably lower because our battery system lasts for 10 years, while the competitor needs to replace their batteries several times during this lifespan, or upscale their battery system so they lose competitive edge. So
So is your technology then? So from what you've said to the audience so far, is you've got a fuel cell development group, and you have a battery element to this. You've got a design element, obviously based on your history as the founder. You come from a design element.
Hmm.
So is part of your company's core competence battery technology then?
I would say electrical integration or system integration in general. And we started off building complete electric drive lines, charging stations, complete electric vessels even. But from 2018 and onwards, we're only focusing on supplying energy systems alone. So that's the core focus or the core competence from now on. So we have a broad maritime experience in the business as such, but focus is on batteries and fuel cell systems now.
So what are some of the differences? And I know in our pre-call, when we spoke kind of preparing for this, we talked a little bit about the difference between maybe the batteries in my Tesla and the batteries in one of your vessels. Maybe talk about the demand, the requirement. What makes it special? Why does everything marine cost me 2x because it says marine on it? Is there different engineering things that are taking place, or what's happening? And you gave one example already, I think, by the life expectancy.
Yeah, that's that's one topic, and the other major difference is the safety aspects and what's related to type approvals. To be able to offer your solutions in the marine space, you need to have what's called a type approval certificate. So that you have classification societies approving your systems that they're deemed to be safe to be used on board a ship. And that is, I would say, in terms of battery development, the most mature and well-developed framework for technical requirements on lithium batteries for electric propulsion. So that's driving complexity to some extent and also costs. But I would say that the biggest driver is the requirement on the application as such. We are supplying what's called lithium titanate oxide batteries, where we're using titanium in the battery. That gives it certain characteristics in terms of power density and safety and durability and long-term reliability. So we're the only business in the world that has this type of type approval for LTO batteries. And we're supplying the safest lithium battery available in the marketplace. And that's one really interesting topic, because that's where we feel that the automotive industry is not as well developed in terms of regulation. There are so many battery-related incidents in the automotive industry and land-based ESS applications. Just looking at GM and Hyundai and other examples where you have massive recall programs for safety related limitations, I would say, in existing battery solutions. So, and for marine applications, it's a completely different matter. When out at sea, it's a complete disaster if you have a fire incident on board and if you can't control that incident. So you can't escape at sea. You need to be able to control it, and it's hard to evacuate passengers and crew. While if you're driving an electric vehicle, you can just drive aside and stop and just walk away from there, but you can't do that at sea. So that's a big difference. Power density, yes. When you're operating a electric vehicle, if you're operating an electric car today as a private person, you typically maybe recharge a couple of times a week. In our applications, maybe you do that 20 times a day, and at full power maximum, what's called C rates. So high power recharging events and a tremendously higher amount of such charging events per day. So that's a completely different matter in terms of what requirements that put on the battery system. So yeah.
So you bring up some points. So safety. You've covered quite a bit of ground there, but you just said something about charging and the rate of charging. So are there these supercharger stations along the shore that you're pulling into, or how are these vessels? What kind of infrastructure is there and required to quickly charge a ferry that needs to turn around and go back out and go on another journey?
Yeah, depending on what type of vessel it is. Historically, the development started off with smaller passenger ferries. So in a city-like context, typically commuter ferries and things like that. And now moving on to road ferries, Ro-Pax ferries that operate typically in some kind of a fixed schedule between known ports. Then it's pretty easy to dimension your battery system and see where you need to have your charging stations. We've supplied a number of projects. One is for the city of Copenhagen. We've supplied the battery systems for 7 new battery ferries, commuter ferries. And in that type of operation, they have 3 charging stations distributed within the city of Copenhagen. And they operate fully automatically. So the ship enters the dock and it automatically hooks up to the boat and connects automatically to the charger, and then it recharges in 5 minutes. And then it takes off again and operates like that, and recharges every hour and operates 16 hours a day. So it's and then in that case, 7-year full-time full value warranty and 12 years design life we have for our battery system in that type of operation. You have charging stations, very much like what you have for electric buses, but you have different means to connect to the vessel. Because the boat can move, so it's a completely different dynamic situation when recharging. So it's a bit more complicated, I would say.
Yeah, cool.
But in terms of technology, and might be a stupid question, not being the engineer on the call, but in terms of the battery density and the volumes that you said, we had discussions on the show before where we had the kind of the pros and the cons with batteries versus hydrogen in terms of trucks. Mm. But would you say that your technology would be suitable also for heavy trucks or at least long distance trucks, or is it more specifically designed than for the marine?
No, for heavy duty type trucks, absolutely. Especially our type of high power batteries combined with fuel cells makes absolute sense. Because when combining batteries and fuel cells, then when you utilize the battery as a power source for peak powers, high power output, not so much for the energy carrying capacity. That's where the fuel cell and hydrogen comes into place. So yeah, absolutely. Although we're not focusing on track applications at the moment, it could be a future development. And comparing batteries, you need to. LTO batteries have had a poor reputation historically because of low energy density per kilowatt hour. But this is important to know that when comparing, you need to compare apples and apples and not apples with pears, because what's interesting is the usable amount of energy you have on board. So typically what we see in our projects is that we are offering a much smaller battery system in terms of installed amount of kilowatt hours, while the competition must install a much larger battery system and utilize a much smaller part of that battery system to be able to meet the long-term requirements. So even if the competitive solution may be cheaper per kilowatt hour to buy, you need to buy more kilowatt hours to make the same job. So that's a hugely important point, actually. So in most cases, we have a lower TCO and a smaller footprint with our battery installations, even though on specificational level, our battery system is more expensive and typically way more.
So I was going to ask about weight. So you went right to what was coming to my mind. So two things come on with the weight. Is it additional ballast, and are you having much more energy to move your vessels because you're using electric batteries, or is that just part of the design of a modern ship and it's just part of it? Help me understand how that works.
Depending on the size of ship, I would say in most cases we're limited in volume. So we built the world's first full-sized electric tugboat, for instance, where we installed nearly 3 megawatt hours of batteries. In that case, you're basically replacing bunker volume. So many tons of fuel oil with battery weight instead. So that type of application is not weight sensitive, it's rather volume sensitive. So we need to make a lot of efforts in trying to squeeze down the volumetric footprint for the installation, not weight. But there are so many other applications where you are weight sensitive. Typically high-speed ferries, carbon fiber vessels where all that matters is weight. And now in Sweden and other places in the world, it's a trend moving over to foil boats to further improve the energy consumption for the vessel as such. And they are even more weight sensitive. So that's a niche application where weight is more important than maybe long-term durability in the battery system. So those type of operators may have to replace their battery system and go and opt for a cheaper and more lightweight battery solution, and then have to replace the batteries every second year or something.
Okay, so I understand the weight and I understand the volume thing. So I assume one of the battery technology evolution is reduction in size is what you're hoping is one of your technology advances over the next few years.
Yeah, we have a new development coming out in the market. We're currently doing a lot of cell qualification tests on a completely new type of cell chemistry, which theoretically has an improvement of 300% more energy carrying capacity, or the energy density improves with 300%. In the first generation we're launching, we're using the same cell can, the same geometry of the cell itself. So on the same weight and volume, we're improving with nearly 40% the energy storage capacity.
Now, is thermal runaway a problem in marine battery type of things? Is that a concern or issue? You talked about safety before.
Yeah.
What's
absolutely.
different here? Why am I not having hot batteries sitting in that tugboat that's just glowing red if I look through infrared?
No, that's one of the most important factors. So related to these type of classification tests I mentioned previously, you have to do a lot of repetitive thermal runaway tests to prove that if you induce a thermal runaway in one cell, that shall not propagate to neighboring cells in your battery module. And if it does, the second layer of safety, or the absolute minimum requirement, is that one specific battery module may go into thermal runaway, but it can not propagate to the next battery module. And we have proven during these tests that our type of LTO battery cells do not propagate between cells. So it's the highest level of safety in that sense, without any active measures at all. So, and there are a lot of safety related details about these LTO batteries that are quite interesting, that I can probably go on for another couple of hours, but we can just stop with saying that this is by far the safest solution.
Yeah, I think that answers my question. I think I'm going to ask one more, and Johan, you can ask a question. I'm sorry, I'm just passionate. You got me excited here. So I also have to assume that the shipyards would have to become a virtual partner of yours somehow to make this all work, because I don't think they're used to building these kind of ships. So tell us about what happens there. How's that working for you?
Yeah, no, it's previously a lot of our projects has been sort of the first project with the customer. So where we have to sort of educate and sort of coach our customers to make wise decisions. One example is a huge establishment in India, where we're part of establishing the biggest fleet in the world of electric ships. Nearly 100 boats are now being built in the city of Kochi in Kerala in India, and where they're hooking up the waterways with the metro system. So electric ships will operate in tight integration with the metro system. So it's a really cool infrastructure project. But that's an example where the shipyard and the end user, the city, have no previous experience from this at all. So it has taken some time to sort of get everyone on board and understand what are the most important factors here. And one interesting observation is that this is the first public tender where they got advice from consultancy companies and everything. So in the specification for this project, they specified specifically that LTO batteries were the only allowable battery chemistry to be used because of the requirements as such on the application. So it's a new interesting trend. So then the first one, to my knowledge anyway, where this type of titanium oxide batteries were the only allowable choice. because of safety and reliability. And yeah, you do run across new experiences when integrating new electric type switched gears on board. You enter into a lot of new phenomena on board related to electric dynamics and what's called EMI or EMC related stuff that is new things to tackle. So often we have to sort of work in close collaboration with the shipyard or the system integrator to resolve issues like that. But yeah, so far so good.
But related to the shipyards, it's also the harbors, so the because the infrastructure needs to be done. And I know from an EV point of view, that was one of the biggest, still is in many ways, the biggest hurdle in terms of procuring an EV channel. You know, how do I charge my car?
Yeah.
I guess for boats, even bigger. You know, you can produce the best battery, you can produce the best electric boat, but unless the whole ecosystem is there to support it, it kind of collapses.
Well, Norway as a lead example in this type of transformation. Typically, how it's done there is when they have a new tender coming out for operators to bid on, say that whatever it may be, slow-going ferries or high-speed ferries. Typically, how they've done it anyway is that the operator who's putting in the bid has also to take responsibility for any shore-based infrastructure establishments such as charging stations or hydrogen refilling stations. So that has to be part of the bid, not just only buying or building new vessels, but also establishing the necessary infrastructure. And that's a bit of responsibility to put on the operator. And in other places of the world, it's different, where sort of you specify these are the boundary conditions. Basically, we will put charging stations here and there. You just have to bid on the operation and build vessels to meet the timetable, basically. So it differs from various regions, I would say. And we're working with Swedish Vattenfall to sort of remedy this catch-22 situation that may appear. So they can take the main responsibility for establishing charging stations and hydrogen refilling stations, and also targeting existing fleet owners, because they also need to address this transformation. It's not just new build. We have, I think, 30,000 or more vessels sailing in Europe alone. And at least a part of that fleet is so new that you need to actually consider to actually convert those boats into electric propulsion. So,
but that leads us to you mentioned a little bit the differences between the countries. So Norway went one way, other countries went another way for the infrastructure alone. But is this? I see this as a little bit of a challenge in transformation industries in general, because you have regulatory differences. So if you're launching or rolling out a battery solution or a vessel solution or an infrastructure solution, it's very difficult to find the return on the investment in one local market. So how do you approach this if all the countries have different rules and different appliances to make this happen?
Yeah. Well, EU is taking one angle to this, not to specify technical solutions, but rather putting other initiatives in place to stimulate the industry itself to seek out the best solution, which is the most technically and commercially viable solutions. So they're introducing, or they proposed, a new tax system within this Fit for 55 framework, this climate law proposal. They were proposing to introduce the marine transportation into a tax credit system for the first time, which means that all ships operating between EU ports or international ships coming into an EU port has to declare the energy consumption on board, whether you're using fossil fuels or whatever fuel you're using, and you will be taxed accordingly. And in addition to that, they will also tax the energy intensity on board, so try to stimulate to reduce your energy consumption on board. So you will actually be taxed if you're using a lot of energy on board, regardless of what type of energy. So that's another way to try to stimulate a more progressive development. And then fossil fuels in general will be taxed when purchasing it also, in addition to that. So it's basically three parts there. And then in parallel, EU is launching massive programs for primarily, I would say, related to hydrogen production and distribution and the logistic systems for hydrogen, and where port facilities is one important area, of course. So there are a lot of parallel activities, I would say, to meet the end goal. So EU has this more of trying to create a foundation with stimulation packages and incentives that will increase over time, starting in, I think, 2023. And then just the tax pressure and the incentives will just increase as technology matures. So I would say that this application when ships enter into port is just the first step. When lying in port, you need to do that under zero emission, but soon there will be requirements when driving your ship into port, you have to do that under zero emission. And I see eventually when entering into EU waters, that has to be done under zero emission operations. So the requirements will just increase and increase over time.
So out of curiosity, what are we talking about? I know this is a hypothetical question, but I got to get my head around it. What are we talking about in times? Because you're building a vessel. This is not something you do on a daily basis. It's a long process. You utilize this vessel for a long period of time. So when EU is putting these demands saying that, yes, in port you need to be zero emission free, in and out you need to be, what are they talking, giving timelines? Because I would assume it's a big switch in order to make this happen.
Yeah, of course, it's a soft introduction of these tax systems, but the idea is to start introducing it already in 2023, and I think, if I remember correctly, 20% of the let me see if I get this right. They will start taxing 20% of the verified emissions in 2023, going up to 100% 3 years later. So it's rather quick. Yeah, fairly quick introduction of that taxation on emissions. And yeah, so that's typically the time frame. And when talking about shipbuilding, most new build ships today, at least if you have a European business, they have to be future proof. In terms of being to be able to be at least upgraded over lifetime to meet the end state of at least cutting your emissions with 50%, but the ultimate goal is to cut it with 100%. So the fit for 55 is 55% reduction by 2030.
So I guess what comes to mind with me is, if we look at the electrification of everything, right? You have cars electrifying, you have boats electrifying. What are the economies of scale? How many boats are coming out of European ports, in and out, or American ports, wherever this is going to take place? Yeah. And is the capacity from many of our audience members going to be there? Or are there projects that are tied to this? Are you working with renewable developers or what to do? Because if you suddenly take thousands of ships and they're very high demand and very power intense, where's all that going to come from?
Well, for the foreseeable future, looking into the supplying batteries into this market, that's not going to be any shortage.
But you have to charge those batteries, right? You have to have some sort of electricity coming in, some sort of power source is going to charge those batteries, because it's probably not the most efficient use to get it to a battery. You're going to lose some energy along the way. And I'm not criticizing. I'm just looking at it as, and we talk to all kinds of projects and everything's getting electrified.
The bottleneck.
This seems like a big wallop all at once.
At least in Northern Europe, the bottleneck is not the energy, the total energy consumption or the forecasted energy consumption as such. Is the power limitations in the various distribution grids. You can't supply sufficient amount of amperes in the cables, basically, to feed the peak power it's required. So it's going to be a completely different mindset here with distributed, localized batteries and fuel cell system to offload the main distribution grids, because that's going to be the biggest need to resolve the whole infrastructure challenges, I would say. So that's going to be an interesting part for our business, actually, looking into port facilities to install batteries and fuel cells to offload the grid, support these type of peak demands that will just increase and increase and increase.
All right, so what I'm hearing you say, if I understood, and I'm not the engineer, much like my colleague Johan here, is that there will be almost like a capacitor or something. You're going to put batteries of things at the port. And so, for that 5 minutes every hour in that example you gave earlier in the podcast, that comes in, that may be a peak moment. Yeah. But during the rest of the time, that battery capacity at the port would charge back up for that next hour, more or less, a pretty simplified example. And then when you come, you peak out and you'll be okay. And so that's part of a project perhaps in the future where you upgrade the port to handle it, because the grid infrastructure isn't in place to handle the capacity required.
And it's not only capacity issue, it's also a cost implication with having high ampere connections, high power connections from the grid. Currently, utility companies charge a lot for a boat. We can talk about maybe a number of megawatt of power connection to recharge a vessel. So it quickly sums up to many megawatts of power required in a port facility. So it's a business case perspective on this as well, where it makes sense. It's a lot cheaper to have parallelized charging station with a low power connection from the grid, supported with a localized battery system. So that's another interesting development going forward from here.
So what does this do to the cost of operation and cost of ownership of a vessel and the lifetime of a vessel? So you obviously change your fuel costs, probably change your maintenance costs as well. How does this compare to if I buy a conventional vessel today or buy an electric vessel today and put them next to each other, what's the ROI on the two?
When I get that question, I say it's an irrelevant question, actually, okay. because it's and I understand we're asking it, but historically speaking, that was a common question where I had to argue what's the return on investment? How many years down the operation does this make sense? But looking into what is the desired outcome of this transformation, it's not a matter of operating on diesel. It's not going to be an option, and it will be taxed so heavily in the future that it's not going to be a business case operating on fossil fuels. So it's an irrelevant question for me. The question for me is, what is the best zero emission solution compared to competition? That is what I'm focusing on. Currently the challenge right now is on the hydrogen side, with energy cost being rather high in this early on market for hydrogen. So that is a substantial challenge, I would say, when looking into various alternative fuel solutions. Hydrogen is still, as an energy, pretty expensive.
Okay, so when I hear you say that,
yeah.
I hear you say it's expensive, but it's worth it because you don't have the choice, is kind of the takeaway that I heard.
Yeah.
So otherwise you would say, well, yeah, it's comparable, but that's not the right argument you're making. So I think it's not inexpensive. And then you're saying is, of the choices, it's the most cost effective. Is that the right response to what you just told me?
Well, my advice is to, as long as the battery technology is sufficiently capable, it's the most energy efficient and most cost efficient operation. But in many applications, the energy density is too poor, basically. So you need to move into something else, and that's where the fuel cells and hydrogen come into place. And in the product discussions we have today, zero emission is required. So you don't have so much to choose between, and then it comes on the total cost there when the operator sends in its tender, of course. But there are short-term other solutions, of course, that are maybe cheaper than hydrogen, but it's not an ultimate solution.
Mhm.
Biofuel-related stuff, etc., etc. But it's still
But you see those as incremental or more of a band-aid, is what you're saying.
yeah. It's not at the end of
Okay.
the century. That's not going to be on the market. That's my
And we're not in the market to buy ships. I was just curious. So I'm not trying to do a critical evaluation. I think it'd be fun to switch gears into more Johan's normal area of questioning. So you're an entrepreneur. You've built this company. You claim you're small. When I've seen some of your accomplishments, then I think you've done some pretty amazing things for a small organization. Tell us a bit about the business. So let's talk about the entrepreneurial side of this.
Yeah. Well, I've nearly suffocated with this business over the years because we've been too early on in the market. So one of my biggest takeaway or experiences is that you need to have stamina when jumping into something like this, especially if you're a pioneer. Absolutely, you need to have stamina and be able to sustain. And actually, it's easy to overestimate the readiness in the market. It always takes longer before it matures than you expect or hope for. So prepare for that. But I feel right now we have a very strong momentum. We have great fundamental qualities in our business. We're supplying the best products available. We have a unique position. We have the opportunity to become a world leading supplier for zero emission solutions, for sure. So it's a very, very exciting time we're in. We're preparing the business to go on the stock exchange within the next 12 months to make sure we have available funding to grow the business over time. So a lot of things.
What do you need to grow? So you said you have at least 100 ferries being built, some contracts. You've talked about you've got things going on. You've got a R&D team, it sounded like, in maybe PEI or somewhere over on the Canadian shore there. So if a company goes public, there's usually something to do to grow, that you've got some massive plans. You need manufacturing capability, you need engineering capability. What is it you need?
We're, I would say, in 3 domains. We need to continuously invest in our product portfolio, R&D investments. Primarily, the biggest cost driver is on the fuel cell side, but also on the battery side. To stay ahead of the competition, we need to continue to be agile and customer focused and continuously fine-tune our product offerings. That requires funds. Production capability wise, we're looking into establishing cell production in Europe and investing in production facilities to expand, and also looking into possibly expanding outside marine. So we need resources for that. And then we're operating in a global marketplace, so we need marketing and sales resources and an organization to cover the global need. We're typically today primarily working through big global customers who have the global outreach and a global presence, but there are many regional customers as well that we do not reach through our big global accounts. So we need to have a regional presence as well, and this requires resources, and we cannot either exclude the possibility that we need to expand by mergers and acquisitions either, that may need further resources.
Is this a race, or are there competitors nipping at your heels as well? Are there quite a few that see the same global opportunity? Or are you still on the leading edge?
Well, in the marine space, there are not that many suppliers, actually. I would say less than 10 really qualified battery suppliers, and very few on the fuel cell side so far. So that gives you an idea. Compared on the land-based side or automotive side, you have so many different possible battery vendors out there. But it's a limited supply base in that sense for maritime, and there are some hurdles. You need to get into the supply chain, and once you're in, you need to have a long-term presence to be able to be an approved supplier in this maritime business. So you need to have to prove your credibility, and that you're that you're in it for the long run, for
So-
sure. So yeah.
Is it also analogous to the EV vehicles for having autonomous driving? Is that a future in naval transport and shipping?
Yeah, absolutely. Yeah, I know of 2 projects or 3 where autonomous operation is required actually. We're not developing solutions to that. We're just supplying energy systems for those type of ships. But yeah, that's a trend for sure, and it's particularly for smaller vessels. Crew cost is a huge part of the total operational expenditure. So there's a business case driver for moving into autonomous operations, but we're not there yet. It will take some time before it's fully mature.
So out of curiosity, I know we're running up a little bit towards time here, but out of curiosity, if we look at the overall number of vessels, if you look at ferries, for example, is there a percentage today in terms of how many that are electrified, and what are the projections, let's say in 2030, in terms of this? It might be difficult to say because you got deep sea, you got to the ferries and all the rest. Is there a number?
Yeah, it is.
And it's a projection.
Well, currently, I looked into some statistics from DNV on this topic. Of the total global fleet today, operating ships, only about 0.3% of those vessels in use today have a battery installation on board. But looking at ships on order, ships being built today, the percentages has increased. So then it's nearly 4% of all ships being built that has some kind of battery installation on board. And looking into Norway, for instance, which is the lead country in the world in this maritime transformation, all ships being built in Norway or for Norway today has some kind of battery installation on board, and that's regardless of ship type, actually. So it's not necessarily only for electric propulsion, but then you use batteries on board for the energy optimization of the auxiliary loads, you can say. So
I guess
that's a trend.
So in terms of opportunity for you, it's massive, both for the new, but also the retrofit, I would assume then.
Yeah, absolutely. And we have only seen the first initial development in this market transformation. So there's going to be so many projects coming up ahead. So very interesting times ahead, I must say.
Fantastic.
Well, I think we're running up against time, as Johan said. I could ask about 50 more questions. I think this topic is just really interesting. I think from our audience point of view, as things electrify and we have more of that, you talked about kind of the charging stations and battery and storage along the way. That's always consistent with everything we're doing based on demand or based on usage. And then for energy transition folks, there's also the obvious no emissions elements, because I look at ships, I look at LNG as a gateway, kind of getting us to a cleaner incremental step, but you're still not at zero. So if the EU said you have to be at zero, I don't know that your LNG ship is getting into port then.
No, that's true. So that's why there are a lot of LNG hybrid ships being built today. So you can actually switch over to battery operation when entering into port.
Oh, nice. So the hybrid, kind of like we saw in the car, we have a hybrid stage going before we get to full electric.
Exactly.
Well, I want to thank you for coming on the show today. It has been a lot of fun. We've been a bit all over the place. I love to hear entrepreneurs doing interesting things. The battery technology in the shipping industry, I think that will be a great help. Bunker fuel is kind of one of my things that it's not the cleanest burning fuel out there by any stretch of the imagination. So I think anything we do to reduce that is probably advantageous for everybody.
Yeah.
So thank you so much for coming on.
Thank you, Chris. Thank you, Johan. It was nice having a chat with you guys.
And for our audience, you spent another hour listening to Insider's Guide to Energy. I hope you've enjoyed this journey as much as I have. If you have, please share this episode with your friends. Do not forget to like the episode wherever you're listening. That helps others know there's great content to listen to. And we'll talk to you again next week.